Good evening. Welcome to Why Do Dinosaurs Matter? We would like to extend a special welcome this evening to some of our local partners, including paleontologist Billy Doran with Fossil Posse and the Museum at Dinosaur Junction and his staff, as well as to let you know that there will be more dinosaurs, as well as many of the themes of tonight's presentation, including their connections to today's birds, at the Betty Ford Alpine Gardens this summer. So please keep your eyes open for more dinosaurs to come. This evening, we welcome Dr. Kenneth Lacovara, who has unearthed some of the largest dinosaurs ever to walk the earth, including the massive 65-ton Dreadnoughtus, which appeared in the recent film Jurassic World Dominion. He is a recipient of the Explorers Club Medal, the highest honor in exploration, previously awarded to pioneers such as Sir Edmund Hillary, Jane Goodall, and Neil Armstrong. His TED Talk has been viewed by over 5 million people, and his book, Why Dinosaurs Matter, available here this evening via our partner at the Bookworm, has been awarded the Nautilus Book Prize. He is founding dean of the School of Earth and Environment at Rowan University and is founding executive director of the forthcoming Edelman Fossil Park and Museum, called by Smithsonian Magazine one of the most anticipated museums in the world. Since 2002, he has served on the board of Colossal Biotechnology, a CRISPR-based company endeavoring to resurrect the woolly mammoth and other recently extinct species. Please join me in welcoming Dr. Kenneth Lacovara.
Thank you, Megan. Thank you, everyone, for being here. I'm going to silence my phone, too. And I can only imagine how proud my late mother would be right now if she knew I was giving a talk in church, right? And she wouldn't have seen that coming either. But thank you all for being here. It's an honor that you all left your homes and came here just to listen to me talk about dinosaurs. So let me ask you a question. Where do you think the world's first nearly complete dinosaur skeleton was found? Let me hear some answers. Portugal. England. North Dakota. So, dinosaurs are first known from England from very scrappy remains, like a jaw with a tooth, some claws, a little bit of armor plate, a little bit of hip. They can't really tell what they are. And so in 1842, Richard Owen, one of the world's best anatomists, gives them the name dinosaur, which means terrible lizard, like it's just a big puffed up lizard. They're not lizards at all. So that's 1842. In 1858, the world's first nearly complete skeleton of a dinosaur is found in Haddonfield, New Jersey. Dinosaur called Hadrosaurus folkii. And it really kind of started the dinomania that reverberates around the world today. Now, you can just shout this out. What's the world's most famous dinosaur? T-Rex, right? It's not even close, okay? So Tyrannosaurus rex is a tyrannosaur. It's in a family of tyrannosaurs. There are about 25 other species of tyrannosaur. And the first tyrannosaur discovered wasn't T-Rex. That was described in 1905. The first tyrannosaur discovered was found in Barnesboro, New Jersey in 1866 in a marl pit, and it's a dinosaur that we call Dryptosaurus. And this is a famous painting of Dryptosaurus by the first paleo artist, really, Charles R. Knight. Now, this painting is called Leaping Laelaps. Laelaps was the initial name for this dinosaur. But it turns out that the name Laelaps was preoccupied by a little species of mite. So they had to change the name to Dryptosaurus. So the world's first nearly complete dinosaur found in New Jersey, and the world's first tyrannosaur found in New Jersey. And at this point in the 19th century, the world's best anatomists, they weren't exactly paleontologists at the time, they were all moving to southern New Jersey for this bone rush that was happening there. And then they found out what was in Montana and Wyoming, and they all moved out there and never came back. So as I travel around the world talking about dinosaurs, I find that there is a great deal of confusion about what is and isn't a dinosaur. So we're going to clear that up tonight. Tyrannosaurus rex. Dinosaur? Yes. Obviously, dinosaur. It's the most dinosaur-y dinosaur, right? How about mosasaurs, the terrible sea monsters of the Mesozoic? Raise your hand if you think they're dinosaurs. Let me see some hands for mosasaurs. How about pterosaurs, like pterodactyls that are in every children's book about dinosaurs? Dinosaurs? How about crocodiles that are still alive today? Are they dinosaurs? How about this little fuzzy penguin? Raise your hand if you think that's a dinosaur. All right, now before I tell you what the answers are, let me tell you how we define what a dinosaur is. Dinosaurs are distinct from their reptilian kin by their enhanced vigor and power. Dinosaurs have a straight up, their legs are right under them, and they're hinged for straight ahead forward motion. They're much more like a mammal than like a lizard, really. Contrast this, and here's some special adaptations for that straight ahead forward motion. Contrast this with the languid, sprawling posture of a lizard, right? Knees and elbows bent, belly dragging on the ground, tail scraping behind. Lizards are always about a half a push-up away from taking a nap, right? That's not the dinosaur posture, right? Lizards, not dinosaurs. So the answers to the questions: mosasaurs, the giant terrors of the Mesozoic seas, not dinosaurs. They branch off before there is the first dinosaur. Pterosaurs, like pterodactyls that are in every children's book about dinosaurs. Not dinosaurs. Your children's books have lied to you. Sorry. Crocodiles are the closest living relatives to dinosaurs today, but are not dinosaurs. And that little fuzzy penguin? That is a dinosaur. I don't mean it's closely related to dinosaurs. I mean it's a dinosaur. Being a dinosaur is a binary condition. You're either a dinosaur or you're not a dinosaur. You can't be like half a dinosaur, right? Just like we can't be half a mammal. And the reason that it's a dinosaur is because it has dinosaurs in its ancestry. It comes from the first dinosaur. Now that's not common sense, you might say. Well, I'm here to tell you that common sense is a poor guide to understanding the universe. That's why we have science. We did the experiment. We tried understanding the universe with common sense alone. That's called the Middle Ages and before. And we didn't know where the sun went at night, and we didn't know where babies came from, and we didn't know where disease came from. And then we got science. And then we got like HBO and air conditioning and all kinds of things. And the world got a lot better after we got science. And so if you come up with an anatomical definition for what is a dinosaur, and then you find the first thing that satisfies that definition, which currently is a dinosaur called Nyasasaurus from Africa. It's about 237 million years old. So you take Nyasasaurus, and 100% of its descendants, well, that describes a group, or what we call a clade, that are the dinosaurs. And if you're in the clade, if you have that first dinosaur for an ancestor, well, you're in the clade. There's no way out. It's like the mafia or the CIA. Like, once you're in, right? And that applies to birds. So if we look at the dinosaur clade, if we look at the ancestral dinosaur, the very first dinosaur, and take 100% of its descendants, you can see the giant marine reptiles, they're not in. The pterosaurs, they're not in. But all the things that you think of as dinosaurs are in, as well as all the birds, right? A ruby-throated hummingbird, a parrot, a flamingo, a penguin. They are dinosaurs to the same degree that a T-Rex is a dinosaur or that a Stegosaurus is a dinosaur. Which answers the age-old question, what did dinosaur taste like? So in my early career, I spent a lot of time in Egypt. I went there to find what were called the lost dinosaurs of Egypt. There was a paleontologist, Ernst Stromer von Reichenbach, who 100 years before went to the Bahariya Oasis in the Sahara and discovered 4 new species of dinosaur, including the iconic Spinosaurus that you might be familiar with. Now, most dinosaurs are known from only single specimens. And Stromer eventually got these 4 species of dinosaurs to the Bavarian Museum of Paleontology in Munich, where they were on display for decades. And then in April 1944, they were destroyed in an Allied bombing raid. So we lost not only those specimens, but we lost those species in effect. And so they became known as the lost dinosaurs of Egypt. Excuse me one sec. So I went with a team, pardon me, of colleagues from the University of Pennsylvania to search for the lost dinosaurs. I'm sorry. I went down the wrong pipe. All right. In the process of looking, we did not find Stromer's lost dinosaurs. I found his quarry. I found the Spinosaurus quarry, and I found 100-year-old newsprint and old sardine cans, but he didn't leave a scrap of bone behind. But in the process of looking, we found this, a new species of giant plant eater, which at the time was the 2nd largest dinosaur, and we gave it the name Paralititan, meaning tidal giant. From there, I began to work in China, and we did some work in the Gobi Desert. I've seen Mongolia, but I've never been in Mongolia, but I was that close. We were right there, and we discovered a new species of giant plant eater that we named Sujosaurus. Now, this is in the group called the Therizinosaurs. Bizarre dinosaurs. They're in the group of meat-eating dinosaurs, but they've lost the ability to eat meat. They have a beak instead of teeth. They have these big pot bellies because they're herbivores. They're fully feathered, and they have like these Edward Scissorhand claws, right? So nightmares, essentially. So a new species of Therizinosaur. And then we did some work in the foothills of the Himalayas between the Gobi Desert and the Taklamakan Desert. It's actually the place in the world that's furthest from an ocean. So we were way out there. And the reason we went there is there was about a 30 million year gap in the evolutionary history of birds. And we knew that there were ancient lake deposits in the area that were of the right age. And to preserve something delicate like a bird, you need fine-grained sediment. Think of the sediment as kind of like the resolution on your computer screen. So the finer the grain, the better your resolution. So you wouldn't be able to preserve something like a giant plant-eating dinosaur like Paralititan in fine-grained sediment because it would never get buried fast enough. You need sand for that. But if you want to preserve delicate features that birds have, you need a very quiet environment like a deep lake, and you need for silt and clay to settle down and preserve the fossil. And we ended up finding eventually over 100 fossils of a 95 million year old bird called Gansus humanensis, and it filled in about a 30 million year gap in the evolutionary history of birds. Really interesting little creature. And then I turned my attention to southernmost Patagonia, down there, Tierra del Fuego in Argentina, a place that had rocks of the right age, that were sedimentary rocks, and they were exposed in vast deposits of badlands. And so it just seemed like the ideal place to me to prospect. And better yet, the closest dig site was about 1,500 miles away. So I kind of had this whole place to myself. So I went down there in 2004 to prospect for giant dinosaurs. I thought that maybe we could find something larger than Paralititan down there. And in that field season, we found this. That's a 7 foot 1 inch or 2.2 meter femur, a thigh bone. That's about the most robust femur that's ever been seen of a dinosaur. Now, that particular bone was isolated. We dug and dug for weeks in that site, and that was the only bone around. We had some other sites and found some kind of scrappy remains. It was a super hard place to work. It was 150 clicks off the power grid, no road to get us there, so I had to raft down a glacial stream to get to the site. And then to get the bones out of the desert, I would hire gauchos and their horses, and we would cover the bones in burlap and plaster and put them on sleds padded out with prairie grass and drag them out of the desert that way. So this is us dragging a dinosaur bone through the desert. That was enough of a result that I could go to the National Science Foundation and get some proper funding for the project. I went back with a bigger crew the next year, and on the first day of the second field season, I found this, another 2-meter femur. Only this time, it wasn't isolated. The thigh bone was connected to the shin bone, and you know how that goes. And pretty soon, the quarry began to look like this. And there you can see the tail of that great beast wrapping around me, and we excavated for 5 winters at this location, our winters, austral summers. I spent over a year living in my tent at this location right there. Not a bad place to live, but it gets really, really cold there at night, and the wind in Patagonia is fierce. And there were constantly, 100% of the time, scorpions living under my tent. So I always had to be careful to stay on that little thin rubber pad that I had there. So I spent a lot of time there. Ate a year's worth of meals in this ditch. This looks like the worst ladies' night ever. And I could usually only afford to rent a really bad front-end loader for 2 or 3 days at the end of the field season. I taught myself to drive the front-end loader. And I like to show this photo to students because you can see at the end of a field season that I'm beat up, right? My hands are kind of puffy and bleeding and bruised. And, you know, when you're in the field, you're never comfortable. You're always too hot or too cold, or you have food poisoning, or you're being wind blasted, or something's happening to you. But it doesn't matter, because every day that you're in the field doing this kind of work, you're seeing something that no human has ever seen before. And you get to know something that no human has ever known before. And when that's happening, all that other stuff just doesn't matter. And I like to talk to kids about, you know, you could be sitting on your couch playing a video game, eating a bag of chips, like you're super duper comfortable at that moment, right? Is that a meaningful experience in your life? Are you going to remember that in 5 years or 5 minutes, right? Probably not. But when you think about it, like all of the most meaningful, all of the most sanguine moments in your life all happen when you're uncomfortable, right? It might be taking the bar exam, or standing up in front of everybody you know and getting married, or giving a talk on a stage, or whatever. All of the best moments in life happen when you're not comfortable. So I like to advise students to, you know, chase experience, chase meaning, not comfort, because that really doesn't get you very far. So here's us taking out that giant femur. Now, this particular field season, we had kind of gotten ahead of ourselves and exposed too much material for us to get it out by the end of the field season. We got very good at like just-in-time excavation by the end of this project. But most of my crew had to leave to be back at classes or to be somewhere else in the world, and it was down to me and another guy, which isn't great when you're excavating a giant dinosaur. So I went to this gaucho bar, way off the grid, no electricity, dirt floor, and I met these 4 Israeli paratroopers that were hitchhiking through South America. And I said, hey, you guys want to help me dig up a giant dinosaur? And they said, well, what's involved? And I said, well, it's really hard work under extreme conditions, and I can offer you little sustenance and no pay. And they went off in the corner for a minute and came back and said, we're in. So these guys here, they were with us for 3 weeks. They kind of saved our field season. The one guy near is in the Israeli Special Forces. One day he's working with a pickaxe for like 13 hours digging a trench, and he's whistling and he's singing Israeli folk songs. And I said, Nir, why are you so happy? And he said, because nobody's trying to kill me. Which I thought was a pretty good answer and rather poignant right now. So these guys are great. We've kept in touch. They've all come to the U.S. and visited since. And that's one of the nice things about working in a field like this is, you know, you don't go to the tourist spots. You really... obviously. But you meet just some amazing people all around the world. So it turns out to be a new genus and species of giant dinosaur. This thing is 9 times the mass of a T-Rex. And if you're that big, I figured, well, what have you to fear? And so I gave it the name Dreadnoughtus, which means fears nothing, right? Dread not. I actually made a list of about 30 names and hung them on my refrigerator all winter long. And when people would come over, I'd give them the list and have them circle names that they liked. And Dreadnoughtus was the runaway winner there. So Dreadnoughtus, about 85 feet long, 2.5 stories at the shoulder, and all fleshed out, 65 tons. That's the mass of 13 bull African elephants. That's the mass of 9 T-Rex. That's about 10 tons heavier than a Boeing 737. Now, it's hard to say what the biggest dinosaur is because it depends what you mean by big. There's the longest dinosaurs, there's the tallest dinosaurs, and there's the heaviest dinosaurs, right? Dreadnoughtus is currently the heaviest, the most massive dinosaur for which we can calculate a weight, because to calculate a weight, you need both the humerus and the femur, and we have those, fortunately, for Dreadnoughtus. But there are some other really, really big dinosaurs out there that are probably in this size class, but for Dreadnoughtus, we can do the math. And we know that it was about 65 tons. We got a surprise when we thin sectioned the bones of Dreadnoughtus. These are the bone cells of Dreadnoughtus. And we could tell from the growth pattern that we saw there that this 65-ton animal was growing fast at the time that it died. So how big could they get? I mean, the chances of the million or several million Dreadnoughtus that ever lived, the chances that I would find the largest one is pretty slim, right? So we don't really know how big these things got, but big. So now with your newfound phylogenetic knowledge, let's ask these questions. Out of these 3 dinosaurs here, do you see the 3? We have Dreadnoughtus, we have Stegosaurus, and there's a ruby-throated hummingbird there. Out of those 3, which pair are more closely related? The Stegosaurus and the Dreadnoughtus, or the hummingbird and the Dreadnoughtus? Well, to answer this question, we can go back in the dinosaur family tree, and if we do this, you can see that you go from birds down to the ancestor of the giant plant eaters and the meat eaters, and then back up to Dreadnoughtus. But to get from Dreadnoughtus to Stegosaurus, you have to go back to the first dinosaur. It's a much greater phylogenetic distance. So Dreadnoughtus and all the meat-eating dinosaurs and all of the birds, living and extinct, are all more closely related to each other than they are to any of the dinosaurs on the other side of the dinosaur family tree. It's not common sense, but it's true, right? That's science. So it's been just a blessing in my life to have Dreadnoughtus in it, my big 65-ton buddy. It's kind of entered the popular zeitgeist. It's been in lots of children's books. It was in the last Jurassic World movie, which was really fun. I was sitting home, minding my own business, watching the Olympics, and it was in an Olympics ad with Shaun White, which was kind of crazy. It's a beer. There's a Dreadnoughtus beer. Mattel makes a Dreadnoughtus toy, which is 5 feet long. It's awesome. And my friend Adam Savage is super excited about it, so he did a video of it. If you know him from Mythbusters, he's a big Dreadnoughtus fan. And I've been lucky enough to be in about, I think, 21 television documentaries. And I was in a few in this past year. This was a really fun one. It's based on something the post office does called Project Santa. And so when kids write a letter to Santa Claus, they actually have a committee that reads the letters, and they pick certain ones out, and they try to make those dreams come true. So little Abby here wrote to Santa that she wanted to be a paleontologist. So in the show, they surprised her with a visit to my lab, and then we went to a fossil quarry, and we dug fossils together. It was really nice. Recently, there was a National Geographic Drain the Ocean special about Dreadnoughtus. They did some really great CGI, and what I loved about this show is that, when we excavate, we expose a bone, and then we jacket it in burlap and plaster, and we get it out of there. So we never uncover all the bones at once. They took my quarry maps and all my 3D scans, and recreated the quarry for the show. So for the first time, I got to see what the whole dinosaur would have looked like if I could have seen it all at once as I was exposing it. So that was really cool. And then, you know this guy, right? David Attenborough. Sir David Attenborough, he's a global treasure, right? And the best nature documentarian ever, and just a hero of mine. Well, last year there was an Apple TV series called Prehistoric Planet, and there was a Dreadnoughtus episode, and these Dreadnoughtus march across the plains, and there's great music, and then the music stops, and David Attenborough goes, "Dreadnoughtus." And then I was just done at that point. Like, David Attenborough said Dreadnoughtus. That was just amazing. And back in 2016, I received an invitation to become a TED speaker. And the TED organization, really just a great, great organization. It's really the best put together and run organization that I've ever seen. And this has just been a joy in my life. I got up there on stage in Vancouver for the first time. Anybody been to TED? Yeah. And so I get up there, there's 1,800 people, and I look out there and, there's Spielberg, there's Bill and Melinda, there's Goldie Hawn. I look over there, there's Cher. I look over there and there's Harrison Ford. And I think, like, what the hell am I doing here? And then I just kind of said to myself, expletive it. I'm the professor, this is my classroom, I'm just gonna do my thing. And I gave the TED Talk and it was going well, and I had like this little meta narration in my head, like, hey, I'm giving a TED Talk and it's going pretty well, and there's Cher. And then I got finished and everybody clapped, and I went down off the stage, and Cher pops out of her seat and gives me a flying hug. And it was just a very surreal moment for me. That led to this book, Why Dinosaurs Matter, which is published by Simon & Schuster in a partnership with TED. So it was a lot of fun to work on that. It's been published in 8 languages now. There's some of them there. I hope they say what I intended. I have no idea. So dinosaurs are first discovered in the mid-19th century, and early paleontologists, early geologists, they can see from the fossil record, from the geological record, that they were there at one point, and then they persisted for a while, and then poof, they were gone. And nobody had any idea why. And there were all these crazy theories. The prevailing theory of the late 19th century and early 20th century was this idea of species senility, that species, for some reason, would just kind of run down like the human body does and just eventually falter and go extinct. And there were other ideas, like maybe sex determination was temperature dependent and it got too hot to make males or too cold to make females or something like that, or maybe us sneaky mammals, maybe we ate all their eggs. Or there was one published paper, I had to look this up to validate it, but published paper, maybe all of the ferns died out, and the author commented on the purgative effects of ferns, and maybe all the dinosaurs, they perished of constipation. So at that point, you're on the wrong track, right? And then another paper came out in 1980 by Walter and Luis Alvarez. Walter was a geologist, is a geologist. His father, Luis, Nobel Prize-winning physicist who worked on the Manhattan Project. They came out with what seemed like another crazy crackpot idea, because they entitled their paper An Extraterrestrial Cause for the Extinction of the Dinosaurs, right? Which does sound a little wacky, but what they were talking about was an asteroid or a comet, we know an asteroid now, hitting the planet 66 million years ago and wiping out the dinosaurs. And paleontologists hated this idea, hated it, in part because they didn't want these two outsiders to solve this enduring mystery of our field, I think. And so people would say, well, okay, well then where's the crater? Knowing full well that there's a pretty good chance that plate tectonics has recycled that bit of crust since then. Well, the crater was actually found off the Yucatan Peninsula, published in 1991, although petroleum companies knew about it in the 70s, but they didn't tell anybody because they're petroleum companies, right? So now we have the theory of the crime, the asteroid, and the smoking gun. And from what I know from LA law, you can't take that case to trial because you're missing something, right? You're missing the bodies, right? So you can't take a murder case to trial without the bodies. So a worldwide search starts for the bodies, and paleontologists are looking for this all over the planet, and I myself look for this layer with the fossils in it in Africa, in South America, in Asia, all over North America. People find a single mosasaur vertebra and a tooth in Poland. Weirdly, exactly the same thing in Missouri, some fish scales in Belgium, and a pile of paddlefish in North Dakota, which tells you that it's a bad day for paddlefish, right? Like that's the totality of the evidence. And then I found what I was looking for in this quarry behind the Lowe's in New Jersey. A layer that I had been working at for years and really didn't pay that much attention to. But then the quarry was going to close, and I thought, well, I'll dig faster. So I raised a little bit of money to rent a corner of the quarry where I could grid it out properly and start to excavate properly and map everything. And then I started to see what we really had there. And so in the last 14 years, we've excavated about 250 square meters. That's about the room right here. So it's taken us 14 years to go through that amount of space. That's how carefully we excavate. And we map everything. We're not dinosaur chauvinists. We map every little oyster that comes out of there, every little clam, everything that comes out of there, because the setting is everything, right? The context is everything. And we have recorded, so the asteroid hits 1,500 miles from New Jersey, probably about the same from here, off the Yucatan Peninsula, blows a giant crater in the ground the size of Massachusetts times 12 miles deep. So imagine what Massachusetts weighs, right? That's a lot. But pulverize that material into like millimeter-sized particles, but it still has the same weight. So you take it up through the atmosphere, you've given that mass a tremendous amount of potential gravitational energy. When that stuff comes back in, it's got to balance the energy books. How does it do that? Well, you've all seen films of like the Apollo space capsules flaming back into the atmosphere. It's friction. Well, friction. Imagine that day, trillions upon trillions of tiny millimeter-sized space capsules, each flaming back into the atmosphere, each heating up a little parcel of air around itself. The result is, globally, temperatures that day get up to somewhere in the range of toaster oven to pizza oven. So the dinosaurs that dominate Earth's terrestrial ecosystems for 165 million years would not see but one day more, probably not 1 hour more. And at this site in New Jersey, along with the bodies, we find the little glass beads that rain down from the sky called spherules or microtectites. We find the shocked quartz, which can only be produced by asteroid impact or nuclear detonation. And we have a spike in the level of iridium, which is what the Alvarezes found in Italy, which is a platinum metal, which in the formation of the Earth, it's heavy, so it sinks down towards the core, but there's no place to sink to in asteroids, right? So the ratio of iridium in asteroids is higher than in the crust here of the Earth. And so we have those things, and it's amazing to look at. This is for a NOVA special that we did. We took 25,000 fossils out of my lab, gridded out a soundstage, and put them all back in their mapped position. It took us 4 days, and we are never going to do that again. But if you had X-ray vision, that's what our fossil layer there would look like. So this kind of brings this story full circle of what happened to the dinosaurs, and kind of amazing now that we see like the deathbed of the dinosaurs in New Jersey, 11 miles from where the world's first discovered nearly complete dinosaur skeleton was found as well. So now I know I have to save this site. Now I know that it's not just interesting, but really of global importance. So I did what paleontologists don't usually do, which is that I invited the public to the site. Usually we try to keep our sites a secret, right, for obvious reasons. So I went into the township building, explained to the head of economic development what they had there. She's like, you ever seen Parks and Rec, that show? She's Leslie Knope, right? She looks like her, she's got that energy, she celebrates holidays nobody's ever heard of. So she immediately flies into high gear, and we become a team, and we decide we're going to hold a community dig day. And we have no money for this. We put a sign on the road. I send out some emails, and I'm hoping maybe we get 75 people. Because in addition to this research layer that obviously we manage and curate very carefully, we have layers above that from just after the last moments of the dinosaurs that are still full of fossils. But those fossils aren't particularly scientifically important. So really their best use, I think, is in education and public outreach. So everybody that comes to this site who's not afraid to get their hands dirty and who tries a little bit finds a 66 million year old fossil, and we let them take it home. And that just becomes a transformational experience for kids, for grown-ups, for anybody. So we have this first dig day. I'm hoping for 75 people. 1,600 people show up. And we are not ready for this, and it was a little bit scary. But then in subsequent dig days, we have 100 volunteers, and we're ready, and we know what to do now. And we would open up registration, and we would open up 2,000 spots, and the 2,000 spots would fill up in 15 minutes with 9,000 people on the waiting list. And we have 600 schools on the waiting list now because the kids really get the authenticity of this. When they pick up that fossil, they're the first human to ever see something. And what are fossils in my field? It's information, it's knowledge. So you pick up a little fossil, and all of a sudden you're the first person to know something as well. And they love that feeling. And it's addictive, and that's what we're trying to do. I always call fossils the gateway drug to the sciences, right? And so we bring kids to the fossil quarry, and we give them a free sample of science, trying to get them hooked on it, right? And what we're really doing is we're inculcating them with the scientific method, which is a way to receive and process information in a rational way. And boy, howdy, do we ever need that today, right? So you can then get that way of thinking, and once that's the way you think, that's the way you think. And we're not trying to breed thousands of paleontologists. The world has just about enough of those. But you can apply that way of thinking to physics and medicine and business and all the things that the world needs. So, I like to think we're growing better citizens through fossils in the process. So I know I have to save this site. I was at Drexel University at the time, very happy there, had the lab of my dreams, but I couldn't get it done there. It was just sort of the psychological barrier of the Delaware River. So I moved across the river to Rowan University, and Gene and Rick Edelman, two alumni of the university, stepped up right away, really understood the promise of this site, and donated $25 million to get the project off, which is just incredible. It's unbelievable. Yeah, it's so great. So we went from this to now it looks like this. And so that is the Edelman Fossil Park Museum, which will open this summer. It's a 45,000 square foot state-of-the-art building. And you can see it overlooks our fossil quarry there. It has an overlook. The old quarry from the 1800s is behind us. It's a pond now. And so now it's a $89 million project if you include the roadway. And so we hired a really great architect, Tom Wong. He works for a company called Ennead in New York. He designs really iconic museums all around the globe. And so I told him what we were doing, how we were really trying to use the fossil record to change people's perspective on not just the past, but on the future as well. And so he started thinking about the camera obscura, which is an ancient device. It's basically a box camera, a pinhole camera that you get inside, and the light comes through. There's no lens, but it projects an image on the wall, and painters used to paint on top of it, and it's a way to gain an additional perspective or to change your perspective. And so he started playing around with this camera obscura metaphor for the design, which turned into this. I took that a couple weeks ago when we had some snow. And there it is from the other side, the quarry side. So it's just beautiful. There's our new road coming into the site. And this is a rendering. This is the upper lobby where you'll come in and you'll see some skeletal material there. And that kind of funnels you back to the main exhibit galleries back there. First decision I made was to hire Gary Staub, who is the world's best paleo artist, world's best paleo sculptor, to make all of our giant life-size recreations. And Gary used to win every year. He would win the National Geographic Paleo Art Award. And then finally they made him a judge so somebody else could win, right? So he's just amazing. Also, like the nicest guy on the planet as well, which is a pretty great combination. And he will stop at nothing to do research before he sculpts a creature. It's really, really impressive. So he's made dozens of dinosaurs for us. That's all I'm going to show you, because we're going to kind of do a little tease as we go into our grand opening and unveil these slowly in our marketing campaign. So sorry about that, but there'll be more to come there, but they are amazing. Here's a kid's crawl through that goes under one of the platforms. Kids can crawl through that, and then their nose to snout with this baby hadrosaur, which will be really fun for them. Here's a clutch of hadrosaur eggs that Gary made for us. And look at this. He puts in just incredible detail. He spent a little time early in his career working for Disney, so he really knows how to lay on the cute when he wants to, you know. So really great stuff. And then we have these really amazing microscopes in certain places that some people who aren't used to using a microscope have trouble using them, but these have like these giant oculars, so it's super easy to use. Look at that little tiny speck of a fossil down there. Right? You can't tell what that is. You look through this giant microscope, and all of a sudden it turns into a 66-million-year-old fish vertebra. So that'll be really fun for our guests. We have a bunch of those. We have some of those where you can see the ejecta fall out from Mexico as well. So we go through two paleo galleries, the Dinosaur Coast, which features the dinosaurs of the latest Cretaceous on the east coast of the US, and then the Monster Seas Gallery, which is chock full of ancient animals that were found on the property. And then really this is the crux of the experience. We go into the Hall of Extinction and Hope, where on one side we lay out our uniquely occurring evidence for the world's fifth mass extinction, in which the dinosaurs and 75% of species perished. But then we take that forward into the Anthropocene and lay out the depths and the urgency of the climate crisis and the biodiversity crisis. And we urge the visitors to get involved, and the way they do that is when you come into the museum, you get a credential with an RFID tag in it. That puts up your own microsite on our website, where you can now keep track of your activities at the museum. So you'll have the Megan page, and every time you visit, you'll accrue points. You can level up as a visitor. When you get to a next level, that unlocks additional experiences, and you can do things at home, like if you plan a pollination garden or make a bee hotel, you send in a picture and you get more points, and you can level up that way. So we really kind of think of ourselves as an activist museum, and we're really trying to activate our visitors to make positive change in the world. This is the Discovery Forest room, which will be kind of like walking into a nature journal, very hands-on, tactile type of room with lots of things to touch and pull and play with. Critter Cove is our live animal center, where we have creatures with some kind of tie-in back to the fossil record. We'll have a large saltwater touch tank in there. We have a really cool 15-minute free-roaming VR experience. So you put on your goggles and your haptic vest, and you get to walk around in this landscape. You'll see your three teammates in your view, and you have to go back to the Cretaceous world, and you're on a mission to collect DNA and proteins and get a biomechanical scan and a color scan, and then get out of there. So that's going to be a lot of fun. Here's our new collections area, and we have plenty of room for growth there. We'll have a really good museum store with some carefully curated scientific content in there. A cafe. Yeah, you ever see the show Cake Boss? There's The Cake Boss opened up 6 cafes around New York City. Well, I hired the guy that opened all 6 of those cafes, so I'm pretty excited about what he's going to be doing for the cafe. We have a 138-seat theater, which folds into flat floor event space, and then, of course, the Fossil Quarry experience, where you can become an authentic explorer. I was in Vail a few years ago. You've seen this, right? You recognize, who recognizes this? This is a really cool playground in Vail that I saw. Well, I tracked down the company that made this. It's a company in Toronto called Earthscape, and they have made an amazing playground for us, a paleontology-themed playground that features a pterosaur, a flying reptile with a 45-foot wingspan, and you can climb up inside the belly and climb up on top and slide down the wings. And so that's going to be really fun. And of course, it's a fossil park. So we have about 1.5 miles of nature trails, which will be expanding. We'll have some gardens going in. And you know, one of the first things I said to the architects was, no fossil fuels at the fossil park. And so the building's been built in a very sensible way, unbelievably thick walls and super thick insulation. You can see, even though we have great views, a relatively low window to wall ratio, reduced carbon concrete, bird-safe glass. Our bird-safe glass works on evolutionary principles in that the basal condition of vertebrates is to have 4 color receptors, red, blue, green, and ultraviolet. Well, us little mammals, in the long nights of the Mesozoic, trying to stay away from dinosaurs, there's not a lot of UV light at night. So we lost the ability to see ultraviolet light. And the gene that coded for that flipped to an olfactory gene. So we have a much better sense of taste and smell than do crocodiles or most birds, except for scavengers. But we can no longer see bluer than blue. So to us mammals, the glass in the museum looks like clear glass, but to birds, who are dinosaurs, it looks like spider webs. And they're evolutionarily conditioned not to fly into spider webs. We lose 1 billion birds a year because of building strike in the US, so it's a big problem. And we put in 72 250-foot geothermal wells. We have this amazing heat pump system that we imported from Belgium, and we will have a large solar array by the time that we open. All of that will combine to make this New Jersey's largest carbon net zero building. So I'm very proud about that. We will contribute no greenhouse gases to the atmosphere in the operation of this museum. So, why do we study the ancient past? Well, that's where the answers are. It was Winston Churchill who said, the further back you look, the further ahead you can see. And when you think about it, it's really all we have. We don't have access to the future, do we? Nobody remembers the future. Nobody can do experiments in the future. And the present isn't anything, right? The sentence I am speaking now is already in your past, right? So all we have is the past. So if you spend the time to learn the language of the rocks, wherever you go in the world, the rocks, they start to whisper to you. Not in like a weird way, but they start to whisper to you. And they always say the same thing. They always say, it didn't have to be this way. It didn't have to be this particular way, because at any moment in time, there are an infinite number of futures that we could have, right? And so we can see from the fossil record that it's just all so contingent. We don't have to have the present that we have now, particularly a present that includes us. When you think about the improbability of you as an individual or our species, it really makes all of us a cosmic lottery winner. You can look back at any moment in the geological past and see this. If you go back to the Cambrian period, this is when complex life is first evolving. And at this point, about 530 million years ago, the first macro predator, it's called Anomalocaris, appears. And it's about 1 meter long, and it's got these weird, scary appendages, this kind of scissor, eraser mouth. And you would go back in that ecosystem and you'd think, boom, Anomalocaris, that's the big winner in this ecosystem. I'm going to put my money on Anomalocaris. Well, there's this weird little squishy centimeter and a half worm thing kind of sliming its way around the ecosystem as well. You probably wouldn't think that was a winner, but this little thing called Pikaia has some interesting features. It has bilateral symmetry. It has a one-way digestive system, which I happen to think is the best kind of digestive system. It's got its sensory organs concentrated anteriorly, and it has V-shaped muscle patterns. Does that sound like anybody you know? That sounds like everybody you know, doesn't it? So if little Pikaia falters, if little Pikaia doesn't make it out of the Cambrian, there will never be dinosaurs or blue whales or hoary bats or wombats or camels or you if this thing doesn't make it out of the Cambrian. And how easy would it have been for that not to happen, right? It's all so contingent. That asteroid that wipes out the dinosaurs and paves the way for the modern world as we know it, well, that formed at the same time that the Earth and the rest of the solar system formed, about 4.5 billion years ago. We'll go out to the asteroid belt 4.5 billion years ago and hit that asteroid with a piece of popcorn, and 66 million years ago, it doesn't hit the Earth. And the dinosaurs, which dominated Earth for 165 million years, were doing just fine. Why not another 66 million more? They'd still be in charge, and we'd still be little mammals if that thing doesn't hit the Earth. Kill off this weird wolf-like creature along the southern shores of Pakistan 38 million years ago, and today there are no whales. Or shift the winds one way or another across North Africa 6 million years ago, and humans evolve or do not evolve as forests turn to grasslands or not. It's like an infinite kaleidoscope of things and events interacting with one another in ways that we will never fully understand. Everything matters. And the more I contemplate the improbability of my existence and your existence, the more gratitude I feel for being alive and for being a member of this species and for living in this wondrous age of ever-advancing technology. And now, what are we doing with our great fortune? What are we doing with this cosmic lottery that we've won? Well, we are using the world's atmosphere as a garbage can. In the last 800,000 years, atmospheric CO2 has never breached 300 parts per thousand. Per million. Not when our species first evolved 300,000 years ago, not when we split from our Neanderthal kin, not when Neanderthals went extinct, not when this country was founded, and now this is what's happening. That's not a mistake in my chart. That's the brick wall that we are all facing. And if we look at wildlife, this isn't species, this is numbers of individuals. 69% of wildlife has disappeared since 1970. 69% since 1970. That's shocking. The planet is running out of its wild creatures. When I started my career, I used to drive across places like Wyoming in the summer, and you'd have to stop every 20 minutes to clean off your windshield from grasshoppers. You've probably had that experience, right, back in the day? I drove across Wyoming 2 summers ago. I didn't have to stop once. Maybe 3 bugs hit my windshield. That's alarming. If you look at the biomass of mammals, so literally put mammals on a scale, what's their mass? Well, the biomass now of humans and our domesticated animals is 96% of the biomass of mammals on Earth. Wild terrestrial mammals, wild marine mammals now account for 4% of the biomass of mammals on Earth. That's shocking. 100 years ago, that ratio was the reverse. If you look at rates of extinction, what I did was I went through the literature and I took the lowest estimate for the number of species on the planet and the lowest estimate for rate of extinction. And so the most conservative estimate, that turns out to be a species every other day. That sounds awful, right? A species every other day. If you take the high estimate for the number of species and the high rate of extinction, it's a species every 13 minutes. So we are losing a species on planet Earth between every 13 minutes and every other day. Any of the results in between are awful. If you look at the background rate of extinction over the last 2 million years of larger creatures, vertebrate animals, well, naturally creatures do go extinct, and the background rate is that we lose about 9 vertebrate animals species per century. Well, in the last century, we've lost 9 species, and these, and these, and these. We know now through geology and paleontology that the previous 5 mass extinctions were all caused by climate crises. The last, an instant climate crisis caused by an asteroid impact. Well, now we are causing a climate crisis that is resulting in the world's 6th mass extinction. If you look at the fringe-limb tree frog here from the cloud forest of Panama, a remarkable little creature that evolved webbing between its fingers, allowing it to glide from treetop to treetop. Well, that particular individual is named Tuffy. And Tuffy lived in the Atlanta Botanical Garden for 12 years, to the ripe old frog age of 12, until Tuffy died. And Tuffy was the last member of his species. A species that was part of a lineage that had an unbroken chain of ancestry back to our 3.8 billion-year-old microbial forebears. A lineage that survived all 5 mass extinctions, that survived the Great Dying 250 million years ago, which snuffed out 95% of species on the planet, which survived the asteroid that took out the dinosaurs and 75% of species, but a lineage that could not survive us. Nor could these recently extinct species. Nor these. Nor the Mariana fruit bat that was declared extinct just this fall. We are now the asteroid. But we don't have to be. There's still time to act to avoid the worst of it, but there's not a lot of time. We are in a situation now where we have to do the hardest thing that civilization has ever done. We have to decarbonize the global economy, and we have to make space for the natural world. And we have to do both of those things very, very fast. And I think if we as a society have to do the hardest thing that we have ever done, then doesn't it make sense that we as individuals also have to do the hardest thing that we have ever done? If you're a person that has some education or some money or a network or some talents, then I urge you to find that thing. Find the hardest thing that you can do and do that thing. Find that thing that you can do and do that thing and do it now, because we are out of time. The time to act is now. Thank you very much.
Ladies and gentlemen, Dr. Kenneth Lacovara.
Thank you.
It was incredible. Thank you.
Thank you, James.
You know what's coming. It's question time. Quickly, and I know we know this, but I'm just going to do it so we don't encounter the hiccup. When I bring the microphone to you, speak into the microphone, not over the microphone or near the microphone, because then it doesn't work like a microphone should. Please stand if you're able. We'll take questions online as well. Chat them in using the Q&A feature, and Megan will read them into the room. And I would love for the young brains in the room to get your gears turning. I'm going to find you. But who wants to get us going with a question? Right up front.
Thank you very much. I just want to know, Didn't you find a Lacovaricist?
I did not. It's kind of bad form to name a species after yourself, so maybe someday after I'm gone. Yeah.
I was just wondering where you got funding for your expeditions before you discovered Dreadnoughtus.
It's hard. You have to be scrappy if you're going to be a field paleontologist. I wrote a mountain of proposals to the National Science Foundation, and a very tiny mound of them got funded. There was some philanthropy involved, and actually I funded a number of expeditions through film companies. I was very lucky to be able to do that. But it's, you learn to run a pretty lean ship when you're a field paleontologist. So, back when I was working on Dreadnoughtus, I could put 8 people on the ground in Patagonia for 4 months for like $25,000. Because we have no place to spend money. Once you're there, you're just living in a tent and breaking rocks. So you can do a lot. I like to think, in terms of like publishing in journals like Nature and Science, like paleontology has the best bang for the buck. Like, I can get a Nature paper for $25,000. If you're working in like genetics, well, maybe $4 million, right?
Okay, I see our next question, and while I'm walking, I'll do a plug for our local organizations. If you're interested in learning more, check out Walking Mountains over in Avon, walkingmountains.org. And then I know Eagle Valley Land Trust would also love some attention from you around this issue. We have a really fun dinosaur community here in Eagle County, and Billy, maybe you'll give us 30 seconds on that later on. Here's our next question.
When is your museum opening?
It will open this summer. We're not quite ready to declare a particular date because it's still under construction and things are happening, but it will be this summer. I will let James know, and maybe he will let all of you know. Awesome.
Since we have children in the room, I'm wondering what the pipeline for paleontologists looks like in terms of in your classes and other institutions.
You mean in terms of what to study, or what do the job prospects look like? Yeah, well, paleontology it's a growth field, and that if you look at the discovery of dinosaurs a century ago, it was about a species a year. By 1970, paleontologists were publishing about a half a dozen species a year. Now it's about 1 a week. There are just a lot more paleontologists, and the world is generally freer now. It fluctuates a bit. So there's more eyeballs on more rocks, and we find more fossils as a result of that. If you want to be a paleontologist, the 2 routes are usually you study geology and or you study biology, right? Paleontology is where those 2 things meet. And then this always, disappoints kids when they ask me what's the most important course. It's English, right? It's writing. Because when you're a scientist, like my product isn't really the bones of Dreadnoughtus. My product is the papers that I write about Dreadnoughtus and other things. I'm a writer. All scientists are writers, right? And so if you want to get your grants funded, if you want to get your papers published, if you want to be a good communicator, you have to learn to be a good writer. And the best paleontologists, I bet, are probably also the best writers.
I have 2 things. One, what's your favorite dinosaur?
Well, that's like asking me what my favorite kid is, right? So, Dreadnoughtus is my favorite dinosaur. I spent a lot of time with Dread, kind of a family member. How about what's my favorite dinosaur that I didn't discover? That would be Spinosaurus aegyptiacus. Spinosaurus is just an insane dinosaur. It's as big as a T-Rex. It's like 45 feet long, has a crocodile skull, has these big claws, was probably a pretty good swimmer. It's reconstructed with this 6-foot sail on its back, although I think it was probably a hump. And it's just, I would love to see a Spinosaurus in real life. And what was your other question?
What is the prehistoric animal called that lives underwater?
Well, there's lots of ancient creatures that live underwater. In fact, life begins in the water. And it takes a really long time for life to get onto land because, life is made of water, right? And so water is a much more comfortable environment for living things than up here in the air. So we go from 3.8 billion years until about 330 million years, so almost the whole history of the planet, until things make their way up onto land because it's such a challenging place to live.
I was wondering, what's the most fossil-rich area on the planet?
So in terms of exposed fossils, we don't actually know the answer to that question, right? But in terms of exposure, you usually want to go to arid places, right? Because you don't have plants and parking lots and things covering up the fossils. So that then, and then you need rocks of the right age. And so, Gobi Desert is fantastic. Several different places in China are just great. North Africa, big exposures there. Patagonia has so much more to go. And then the US West, Montana, Utah, Colorado to some degree, are great places to look for fossils.
Kind of a two-part question, but what kind of inspired you to go into the paleontological field?
Well, when I was a kid, I grew up on the coast in South Jersey where, within sight of Atlantic City on the bay, where there's sand and mud. And then a woman brought a box of rocks and minerals and fossils into my Cub Scout meeting, and I literally didn't know these things were in the world. And it just kind of blew my mind. And I wrote an essay in second grade then, a few days later, about igneous, metamorphic, and sedimentary rocks. And I wrote that sedimentary rocks were the best kind of rocks because you could find fossils in them. And now that I have a PhD in geology, I can confirm that they are the best kind of rocks. But then, neither of my parents graduated high school because of World War II. They had. Thank you. So I didn't really know how to get from A to B. I suppose the only people I knew that went to college were my teachers. So at some point later in my childhood, I thought, well, maybe that's not for people like us, and I found out I was pretty good at playing the drums. And so I just threw myself into it, just practiced incessantly all the time. My wife says my motto is, why do it when you can overdo it, right? And so I just drummed my way through high school, went into college, but then left college, went out to California and played out there, did some touring, came back, was the house drummer at the Golden Nugget Casino in Atlantic City for a year. Played about 800 shows there in the 1,000-seat Opera House. It was just great. It's what students call. Oh, is it? I don't think so. Nope. It's what students now call a gap year, but back then we just called it dropping out. But then something remarkable happened. In 1980, Carl Sagan's book Cosmos came out. And I read that book. At first, I was trying to read it a chapter at a time in the bookstore because I couldn't afford to buy it. But then it was actually gifted to me by my girlfriend at the time. And I read it, and I felt like Carl Sagan had written that book just for me. And I just felt like he had just drilled into my brain. And I thought, no, I have to get back to my childhood roots, and I have to find a way to become a scientist. So I got myself back in school, and I did well enough to get into a good master's program at University of Maryland, and then got into a really good geology program at University of Delaware, and then got so lucky right out of the gate. Got a job at Drexel University in Philadelphia, and then hooked up with this research group at University of Pennsylvania, which is literally across the street from Drexel. And we started talking about Stromer's Lost Dinosaurs of Egypt. And through a weird series of interlocutors with an LA film producer, we actually got Anne Druyan, Carl Sagan's widow, to sponsor our first expedition to Egypt. And that was my start. And then that year, we had a science paper. We had discovered the world's second largest dinosaur, and we had a 2-hour A&E documentary narrated by Matthew McConaughey. So it was a pretty good first year, but it was a very improbable route for me. And I still play. In fact, I'm going back to Dick Strong's house later tonight, and I'm going to sit in with the band. Yeah.
Well, you kind of answered my other question, which was how did you get into, like, what was the methods of which you got into paleontology? So
yeah. I'm very, very fortunate, but I'm also reminded of a quote of Henry Ford's, which was the harder I work, the luckier I got, you know? So it's a little of each. I mean, certainly I've been the recipient of great good fortune, but I work my butt off too.
I just got another question. What do you think, what are your thoughts on the ideas of de-extinction or the morals and ethics? Like, I know people are trying to bring back the woolly mammoth by, I believe, 2027, and
yeah,
I just
us
wanted
people.
to know what you think.
I'm actually, I'm actually on the board of scientific advisors of Colossal, the de-extinction company that is trying to do that. And so here's how I look at it. This is a moonshot that is accelerating the development of CRISPR technology. And you know, the animals that we're talking about bringing back right now, the mammoth, the dodo, the marsupial wolf, well, they belong in this world. The mammoth goes extinct 3,300 years ago. That's a world that has pyramids in it, and written stories, and beer, right? So, like, that's this world. We killed the mammoths. We killed the dodos. We just clubbed them and used them for, like, firewood. And Australia put a bounty on the Tasmanian tiger, and then we killed them all. And there's a heartbreaking movie of the last one in, I think, 1933, pacing back and forth in a cage. So they belong in this world. They're all keystone species in their ecosystem. But I think more importantly, the technology that we're developing to do this can be used as well to keep species that are on the brink and to maybe pull them back. So, you know, you've heard of the northern white rhino, which is down to 2 females, which is not very hopeful. But imagine if we could use this kind of technology to pull some of those species back and to help, you know, to help extinction not be quite forever. This is in no way the answer to the biodiversity crisis, so don't get that message from it. This is a way to bring back very few selected species that have a keystone importance in modern ecosystems. But, you know, at the rate of a species every other day or a species every 13 minutes, this is not the solution to that. We need big global solutions for that.
From our online audience, can you comment on the walking whale in Egypt?
Yeah, so there's a beautiful evolutionary record of that weird little wolf-like creature that I showed from 38 million years ago from Pakistan to the whales today. And part of that record goes through Egypt. In the Fayum oasis, a whale known as Basilosaurus has been discovered there many, many times. And Basilosaurus is a giant whale, but it still has legs. It's not quite a whale yet, right? And so there's this, there's one, an earlier version is called Ambulocetus, and so it's really a walking whale, and then you can kind of see the legs getting less and less pronounced and the flippers developing, and so it's one of the great evolutionary series in the fossil record.
There are scientists drawing T-Rex with feathers now. Is that true? Is it based off of DNA, or is that just people with imagination that are trying to come up with something new, something different, something to get the world's attention?
That's a great question, and I like your skepticism. That's very important in a scientist. No, it is based on science. Now, we have never recovered feathers from a T-Rex, and that's because to to preserve big bones, like the bones of T-Rex, you have to bury them very rapidly. You have to make a rapid transition from the biosphere to the geosphere. So that means sand. It means, the point bank of a river or an inlet channel on the coast or something like that. That's not the kind of sediment that's going to preserve feathers. So why are they starting to put feathers on things like a T-Rex? Well, because if you look at the clade that T-Rex fits into, that bracket that T-Rex fits into, on one side are birds, and on the other side are small feathered dinosaurs like Velociraptor, for example. So it's the simplest assumption. We call it parsimonious. It's parsimonious to think that Velociraptor and birds got their feathers from the same place, right? Rather than evolving them independently. And if they got their feathers from the same place, that means T-Rex has a feathered ancestor, which means that its ancestors could have provided the genetic material for feathers. So T-Rex either, was feathered or at least had feathered ancestors. So a lot of artists now kind of try to split it a little bit, and they'll put like just some feathers around its collar or something like that. But it's not crazy to think that it had feathers, but we don't know that for sure, and we don't know where they would have been on the body or the extent of them. Velociraptor, by the way, you've seen it in Jurassic Park, and it's this thing that's about this tall, and it opens kitchen doors and cooks pasta and does other things. Velociraptors are little. A Velociraptor skull is this big. It's the size of a turkey, right? So if you have a Velociraptor in your kitchen, it's more of an opportunity than a problem, right? So.
Hi, just kind of maybe a fun one for you. Given how much you know about the era and also how long you've lived in rugged conditions, if you were, say, transported back to your hometown in southern New Jersey 67 million years ago, how long do you think you could survive? What do you think would get you? Just imagine.
I would be in about 70 feet of water, so I wouldn't last all that long, but I would also be in an ocean that had mosasaurs. And a mosasaur would eat me like an M&M, right? So it wouldn't even chew. It just might not even notice. It'd be like getting a gnat in your mouth. So I think we have a question over here.
I'll bring you the mic.
Hi, so I have more of a creature question, just because it's fascinating to me. Larger dinosaurs like Dreadnoughtus, T-Rex, things like that. It's always funny to me to imagine them resting. So, what do you think? Do you think something like a T-Rex? Do you think it would have probably just slowly lowered itself onto the ground and plopped down on the ground, or do you think some dinosaurs could have slept standing up, similar to horses do?
Yes, I think both happen. So for something like a T-Rex, they're bipedal, so they're pretty mobile, and so I would not be surprised if a T-Rex could lay down on the ground and rest. I think you'd have to ask Anthony Martin, who's like the world's track and trace expert on dinosaurs, but I think there is something that some people have interpreted as a T-Rex resting trace. Big things like Dreadnoughtus, I don't think they could lay down. Their legs are very columnar. They're basically like a Greek building, right? When you're 65 tons, you're not doing anything fancy, right? So I don't think they could lay down. In prehistoric Planet, they had Dreadnoughtus up on their hind limbs, like fighting with each other. If you look at it closely, at one point they're on one leg. That's not happening, right? They're 65 tons. Elephants, when they walk, usually only have one leg off the ground at a time. If you watch an elephant, they do this shuffle where they always keep 3 legs on the ground. So they always have like tripod, 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 tripod. So it's very stable. I would be almost sure that things like Dreadnoughtus did that as well. So yeah, I mean, a big sauropod like that, first, lifelong obsession with eating, right? And what they would do, the neck of Dreadnoughtus is 40 feet long. So stand in one spot, spend an hour or two clearing out this feeding envelope of vegetation, taking in tens of thousands of calories, and then go and do it again, right? I think that's pretty much your Dreadnoughtus day. Yeah.
This has been awesome, super interesting, super fun. I just have a question about kind of going back to your mammoth research and the CRISPR. What do you think the impact will be on the environment, on the ecosystem, if we do reintroduce those keystone species? And how could that impact kind of the adapted ecosystem without them?
Well, of course, it'll be different in the case of each species and each ecosystem. In the case of mammoths, they were really the keystone species that kept the Siberian steppe, right? And they were able to process the plant material that was there, and then it's available to all the other things that live in the ecosystem. But they did an important thing, is that in the process of feeding and doing all the other mammothy things that they do, they would churn up the tundra, they would kind of rut it, allowing it to freeze more deeply, allowing the cold air to kind of get down in those crevices. Now, if it's frozen very shallowly and we get a warm snap, it can thaw, and if it's a peat area, like much of it is, now we're emitting methane gas, which is like 60, 70 times more powerful than CO2 as a greenhouse gas. So I think the mammoths back in their ecosystem would have carbon sequestration, or at least the amelioration of carbon release advantages. Something like the Tasmanian tiger back in Tasmania. Well, right now the Tasmanian devil, a little marsupial, is suffering from this horrible transmissible disease that infects their faces and they die these horrible deaths. That doesn't happen if you have an apex predator in the ecosystem, because an animal gets a little bit sick and it gets preyed on, and then it's not communicating with the population and spreading the disease all over the place. And one of the reasons why the Tasmanian devil populations are doing so poorly right now is, probably that these weak, sick individuals aren't being culled out of the population by a predator. So, these are all ecosystems that persisted for hundreds of thousands, millions of years without us. And the best thing we can do for them is to try to reset them to their pre-human conditions.
Dr. Lacovara, before we close, by way of kind of final thoughts, I wonder if you could share things we might expect to hear from the paleontological world, or things that you're really excited about, aside from the opening of the museum, which I think everyone has now put on their calendar.
Great. Yeah, I think molecular paleontology is really the new frontier in paleontology. If you go back 30 years ago, there's this kind of fairy story in geology textbooks about how a fossil is made, which is the animal dies, it gets buried, all the meat decays away, groundwater flowing through the bones carrying minerals in dissolution precipitates out in the bones, and the bones become a mineralic copy of their former selves, right? That's the story. Well, now we know, thanks largely to the work of Dr. Mary Schweitzer at North Carolina State, if we cut up a little piece of dinosaur bone, and we do this in my lab quite frequently, demineralize it with an acid called EDTA, almost always what remains behind is original endogenous dinosaur tissue. Collagen, sometimes another protein, blood vessels, bone growing cells. And so our notion of fossilization has a long way to go now. We're back to not really understanding the process very fully now, which is interesting. That's a great place to be in science, right? We have something to figure out. But we can get like collagen protein, and we can validate that it's really from those animals, not like a worm crawling through later and contaminating the site. We can do it in two different ways. One is that you can sequence it and compare it with the BLAST, it's called the BLAST database of all proteins. And if it's truly from a dinosaur, it should fall out between birds and crocodiles, right? And it does. You can also raise anti-collagen, anti-avian antigens, antibodies, and expose them to the material, and they recognize it as dinosaurian and they attach. So we have two different ways to validate that. And so now we're just at the cusp of this, but I think we will get to the point where we start to study dinosaurs and these other ancient creatures more like a biologist studies creatures that are alive today than like geologists would have studied them in the past. So I think that's a really exciting frontier ahead of us.
Ladies and gentlemen, Dr. Kenneth Lacovara.
Thank you very much.